Let us know some more terminology used in illumination model. One of them is ambient light. It is the background light that we can apply in our scene, so which is considered as a uniform light. There is no bright spot in because of this particular light, so that is known as ambient light. So what's the contribution of ambient light in a scene? We'll get to that soon, but as of now just remember that ambient light is the background light plus it is uniform and it will not have any bright spots. Well, apart from this, you also need to know what is the coefficient of reflectivity. Now, as you all know, it is the light reflected from surface. It is the ratio of light reflected from surface to the total incident light. So this plays an important role in what is the color of the object that you actually see. So these things we'll be using in our illumination model, and it is 1 for white. The coefficient of reflector is 1 for white and it is nearly 0 for black. So if you take any illumination model, you will have three things for any 3 points or 3 components. So those are, the first one is being the ambient reflection. This ambient reflection is because of ambient light. Whatever the ambient light falls on a surface, and because of which there will be some reflection, that is known as ambient reflection. Second one is diffuse reflection. This diffuse reflection is a reflection produced because of the light fallen on the object because of diffuse light. And third one is specular reflection. So as we have seen earlier, the specular reflection is a bright spot seen on an object, which happens usually when there is a shiny surface and a spotlight falls, whenever a spotlight falls on the object. Let us learn each of these ambient, diffuse and specular reflection in slightly in more detail. First one is ambient reflection. Well, this is, as I mentioned earlier, it is because of the ambient light falling on an object. So you can say here IA is the intensity of ambient light, Ka is fraction reflected, the fraction of the same that is reflected from the surface, which is this Ka is between 0 to 1. You can calculate the amount reflected by an object because of the ambient, so ambient light, and which we call it as ambient reflection. That I can be calculated using this IA into K. The second is diffuse reflection, which is also called as Lambertian reflection. This is this diffuse reflection is typical of dull matte surfaces, and it is independent of the viewer's position, but it does depend on the light source position. To understand how diffuse reflection is calculated, we need to understand what is Lambertian law. To understand the Lambert's law, one must know that the amount of light striking the object will not change with the object position, because the light is coming uniformly from all directions. So that's the one thing that we have to keep it in mind. And secondly, the object will look the same unless source of light is changed. So these are the two things that we need to keep it in mind. And one thing we need to observe is whenever a ray is striking the surface of the object, the more light is emitted perpendicular to the surface, that is here, rather than, like, let's say if in any other dish, the amount of light reflected will be more whenever it is reflected in a perpendicular position, rather than maybe when it is making an angle with the surface, or maybe it is less amount of light will be reflected when it is nearly parallel to the surface of the object. So more is here, lesser here, and compared to these two, it will be very less in this particular direction. So finally we can state what is Lambert's law. It is the reflection of light from perfectly diffusing surface It varies as the cosine of the angle between the normal to the surface and the direction of the reflected ray. So what we are trying to say here is, if this is the surface, maybe a flat or maybe a curved one, the reflected, this is, let's say this is the normal and this is the reflected ray. Obviously the ray would have come from here. So the cos of this angle, let's say if I take it as I, the cos of this angle is what it determines how much of the amount of light will be reflected. And so as your cosine, the cos of this reflected angle, or the angle between the normal and this varies, the amount of light reflected will also change. So there is a added on law, or the Lambert's law, which is also called as Lambert's cosine law, which says that the reflected energy from a small surface area in a particular direction is proportional to the cosine of the angle between that direction and the surface normal. So that is what the Lambert's law says, and that is what we are going to use it in diffuse reflection equation.